Hey, all right. Thank you. On behalf of Chimes iHeart Ruby team, which is myself and Brant over there. Say hi, Brant. Uh, welcome to our sponsor session here. We also have a couple of other Chime employees here. If you could also other Chime employees raise your hand. Okay. A significant percentage of the audience is Chime employees and have heard much of this before. Chime is a financial services company that targets people who are otherwise not well served by the traditional banking system. People who are living paycheck to paycheck. People who are really looking for an option that does not involve uh, being a part of the traditional banking system. We solve a lot of hard and complicated problems to try and make things as easy as possible for our members. If that interests you at all, please come and talk to one of us about opportunities that you can have at Chime. I will say the signage says that we're going to be at the job fair. We will probably not be at the job fair, but any of the people walking around with Chime t-shirts will be happy to answer your questions. So, I said that we're part of the iHeart Ruby team, which I think begs the question of what an iHeart Ruby team actually is. And I describe it as Chime's developer experience team, the part of Chime's developer experience team that is specifically targeting Ruby developers and Ruby tooling. So that's kind of my lookout. And Brant has just recently joined the team, and that's what we try to do for Chime's, several hundred Ruby engineers and several dozen Ruby teams. And so that involves a lot of different things. We're going to talk today about dependency management. We're going to talk a little bit about internal tooling. We also sort of own internal Ruby standards and practices. We do some internal community management. We run Ruby onboarding. We monitor Slack for general Ruby questions and get pinged whenever somebody has a problem with bundler or something like that. So it's a wide variety of stuff that we do to support Ruby development at Chime. And I'm going to talk about one of our pieces today, and Brant is going to talk about another. So I'm going to talk about the problem that we have managing gems across services. So Chime is not exactly a microservices architecture, but it's not exactly not a microservices architecture. We have over 50 separate Rails apps running internally in our code base, which leads to there are some advantages to that in terms of taking advantage of the sweet spot in terms of the size of Rails applications, but there are definitely some disadvantages in terms of dependency management across all of our different services. And in particular, we use hundreds and hundreds of Ruby gems. I believe if you count our internal gems, the count is over 1,000. I think we just pinged over 1,000. I think that's going to be true of any large scale Rails application. And those gems are continually going out of date. We need to continually monitor stuff. We try to get teams to keep, especially the most important, we try to specify preferred versions of the most important gems, but there's a bunch of different services, and the question becomes like, how do you monitor them? So keeping everybody on that same page is a bit of a challenge. One important part of that process for us has been trying to visualize what our entire ecosystem looks like. We came to the conclusion that it was much easier to manage the problem once we had a sense of the scope of the problem. Like, where do we have problems updating? How big are these problems? How far behind our teams and things like that? And we had no real easy way to answer that question system-wide. And so we built one. We wanted to answer questions like, how many point versions of Rails do we have in production? A staggering number of point versions of Rails are currently in production at Chime. How many teams are behind on major dependencies like Ruby, like Rails, and how far behind are they? And most importantly, are we getting better or worse? Like, are we keeping up with new dependencies, or is stuff getting updated and we're just falling further and further behind? The thing about these kind of dependencies is you always wind up in a situation where you want to upgrade on your schedule rather than have the upgrade be forced on you because some sort of dependency management issue requires you to update and scramble to update a bunch of services in a short period of time. You're trying to avoid that eventuality. So I want to, in order to generate data, and secondly to sort of manage this process, I wrote a dashboard. And I took all of our repos and wrote a data parser that takes all of our Rails apps and all of our internal Ruby gems, grabs their gem file, their lock file, their gem spec, their Ruby version file, their Rails applications config application RB, because we were tracking Zeitwork adoption for a while and we were getting it from there, and grabs their Docker file, because in our system, the Docker file is actually the source of truth as to what Ruby version is actually being run in production. And I wrote a big chunk of parsers that gives every repo a dashboard like this. It says that for every repository, it gives them a score of how far behind they are in general. This is the repository. This is one of the few ones that the comms team would let me show, which is the one for the dashboard itself. It says how many, we've got an activity monitor, how many pull requests have been approved in this gem, in this repository in the last 30 days. It's telling me what the Ruby version is, what version of bundler it's on, JMalloc, Rails version. And then for every gem, for every gem that it uses, is it the current version? If it's not the current version, how far is it behind the current version? Is it out of policy, which we'll talk about in a second? And then it just sort of lists all of them. Is it pinned? And specify for it. The gem dashboard, because it's basically a team of me, we can keep quite up to date. Other of our services have slightly spicier dashboards, which they didn't really want me to show you. We also on the flip side can do the same thing for Rails. So for any gem, so we can also see this for all of our gem dependencies. We can see what the current version of the gem is, when it was released, how many repositories are using it, and then it lists all the repositories. And actually, it will also list all of the pins, all of the bundler constraints that are set. So if something has it pinned to, has pinned Rails to tilde 7.0.0, or if it's, we have some things that set hard ceilings on gem versions, we can see the list of all of them. So yeah, okay, like this. So it has the pin, and then I got a request to actually explicitly display the highest and lowest allowed version, which allowed me to invent 6.1.infinity as highest allowed version of a gem. So there's actually an object in here called fuzzy version that allows you to specify infinite subversions, which was fun. We actually also now, it didn't when I put these slides together, but I do now have a specific report of like which specific pins are causing us the most constraint. So we have a lot of services that pin like an AWS gem, because there was a bug at one point. We didn't go back and put it, and we haven't gone back and fixed it necessarily, but it can say like how many services have that pin, how far behind it is, and how much it's costing us. We also can specify reports for specific upgrades. So I can say like define an upgrade of anything that's still on Ruby 3.1 that needs to get updated to Ruby 3.2, and I can get a nice listing of all of them and put some notes on it, and then we use it to track that behavior over time. There's also a time series graph that I'm not showing here of certain behavior over time, which is also the better or worse question. So a couple things that we learned from doing this, one of which is it actually forced us to define explicitly what it meant for something to be out of date. And what that's sort of a social construct and not necessarily a technological construct. And we wound up defining it as 90 days plus end of quarter. So if a gem got updated tomorrow, the previous version of it would still be like in policy and not out of date for 3 months. So that's December, January, February, and then the end of that current quarter. So out of the date that it would become out of policy would be the end of March. And the reason we did the end of quarter bit was it's a social reason. It's to allow teams to look at the beginning of a quarter and plan ahead all of the things that they might need to upgrade during that quarter, and know that nothing new is going to jump onto that list, because anything new will automatically part of the next quarter. So the idea here was to give teams a little bit of consistency in planning, if they were, and to hope to encourage teams to plan their own upgrades for all of these tools. In terms of like on the technical side, it turns out that parsing lock files is actually quite easy. Bundler provides a tool for it already, because Bundler parses them. But actually parsing the gem files and the gem specs, which are written by people, is much more complicated. The gem spec, because the lock file is produced by Bundler, it's much more consistent, and so the parsing of it is like very, very simple. a gem file or a gem spec where you have to worry about like, are people putting spaces after the operators as they set the constraints? Like that gets a lot more complicated, and to the extent that you can avoid doing that is definitely worth the time period. And it actually turned out that we were doing better than I thought. Dependabot, we had a push to get a lot of teams like sort of auto push through Dependabot minor gems if they passed tests, and that actually helped a lot with most of our smaller gems, like Rails upgrades, are still complicated and things like that. For some reason, we have a lot of old gems that are pinning an old version of Rake that's 8 years out of date, which looks bad on the metric, but doesn't actually affect anything since we don't actually use that for anything. So stuff like that. We actually were able to point to doing better than I thought. And using this tool as a visualization, we have been able to encourage teams to move out of Rails and some other dependencies faster than they have been beforehand. And another thing is like it's very easy to forget version pins. There was a bug. We set a ceiling on this gem so that nobody would get to the bug version, but then the follow up of somebody coming back 6 months later to see if that bug has been fixed, and we can then continue to move forward. Like that's the hard process, and we're just starting to put together just have some visualizations that just went up now to like encourage that process a little bit more. So that's my part. Thanks. We'll take questions together at the end, but I'm going to pass it over to Brant, who's going to talk about personal identifiable information.
Thanks, Noel. Hi, everyone. My name is Brant. Like Noel mentioned, I recently joined the iHeartRuby team at Chime, and it's been a really great opportunity and just excited to be here and share a little bit about what we've been working on. So the topic I'd like to share about today is masking PII. So what is PII? PII is an acronym for personally identifiable information. So this is just any data that can be used to identify a specific individual. So this could be like first and last name, email, social security number, and a whole host of things, including like IDs, like a marketing ID, for example. As a quick aside, I will share a little bit of my PII. I started writing Ruby in 2017. Those are the versions of Ruby and Rails that I was working with at the time. And I joined Chime about 2 years ago, but like I mentioned, just recently joined the iHeartRuby team in September. This is my first time at RubyConf, so really excited to be here. As a quick personal anecdote, I tried to go to RailsConf in 2020, and of course that was canceled for obvious reasons. And then last year I tried to go to RubyConf, and I was selected to serve on a jury trial. So it's been a long challenge, but finally I made it to a Ruby conference. And then here's some of my Ruby takes if you want to argue about random stuff like that. Happy to do so. Okay, so most organizations handle large volumes of customer PII. So this is a problem that I think a lot of folks here can probably relate to. And it's an important challenge. And the problem, again, what we're trying to solve, stated here more clearly, is how do we prevent PII from entering logs and from being output? So how do we make sure we're not writing PII in places we shouldn't be writing it? And how do we obfuscate it if, for example, you're working in a terminal session and you're in a production environment sifting through data? So here's just a few examples. You can see like what PII might look like if it were to be masked or not. There's different approaches, but the general idea is you want to obfuscate enough information so that it's no longer personally identifiable, but it can be nice for debugging purposes to still leave a fragment of data so that you can distinguish two different pieces of PII that might otherwise look identical. So for example, you can include like the domain of an email address. but obfuscate the first half of it. So what I'd like to do is just dive into a couple of simple code examples to illustrate how we're thinking about this problem and some of the techniques that we've been using to handle PII. There is a little bit of Rails here, but I would say this is pretty generalized, and some of these ideas can be applied outside of that and in other frameworks. So this is a pretty simple example of what we're hoping to achieve. Suppose you have like a user object, and maybe the user object has a phone attribute. What we like is, for our logging purposes and in the terminal, we want to mask the value of that phone number. So what we might do is we might like to introduce like a wrapper object that handles that for us. And that's sort of what this is proposing here, is that rather than just having the phone number stored as a string, have that introduce a layer of indirection so that there's an object containing that, and then that object has control over how that data is shown. So for example, if you were to interpolate that into a string, then what you get is not the phone number itself, but the masked form of the phone number. And similarly, if you were to call a method like inspect, it's also going to mask the PII. So here's a couple more examples of what we would like. So we definitely want to preserve certain critical behaviors that your code probably relies on, like method calls like the present method, or value equality comparisons. We want to preserve those behaviors. We don't want to get in the way of that. So that's another consideration for what this sort of solution needs to include. And then finally, if you needed to actually access the underlying PII for whatever reason, there should still be a mechanism that can provide that. So this is sort of like an example, a very simplified example of what that wrapper class could look like. So we're referring to this as a maskable value. This could be sort of like a parent class, and then we could introduce a hierarchy. So there's derived classes that inherit some of the behavior, but then maybe add extra tailored behavior for particular types of PII, so like email or phone, for example. It's really simple. Just introduce some instance variables for the field and the raw value, and then have like a method to access the raw value, sort of like an escape hatch, if you need that behavior. And then the maskable value, the masked value method is what actually performs the obfuscating of the PII. So here's like a generalized form of that. You can decorate however you like, but the idea is you say what kind of field it is, and then you just can say that it's redacted. And then in this code sample, this is illustrating what a child class might look like. So here we can override the maskable or the masked value method and provide like a little bit more custom style of masking. So in the case of phone number, we can just grab the last 4 digits of that phone number and interpolate that into the string. So what can we do with this sort of wrapper object? Well, one idea is we can integrate this into our framework. So we could introduce something like a Rails domain-specific language to automatically perform this wrapping for us. And that's sort of what this is trying to accomplish. So the idea here is like, let's suppose we introduce a method called protect. And this method the idea with this method is you give it a Rails attribute. So if you have a Rails model, like a user model, and it has an attribute you want to protect. You want to wrap that with one of these maskable classes. Then you can invoke the method, you can specify what the attribute is, and then you can optionally sprinkle in some other features, like perhaps you have a mechanism where you can infer what sort of type the attribute is based on its name. So maybe you have like a mapping or some sort of regex. So having sort of like a type mapping from the attribute name to the derived class. And then you can also add callbacks to have support additional behavior if you want to like invoke a method before or after wrapping your PII. So this is kind of illustrating what that might look like. And then here's an example of how this could be applied. So just a pretty simple use case. Let's suppose you have like some domain object like a contact that, let's say it's an active record or application record. What we can do is invoke this method from our DSL protect, and we can specify which specific attributes we want to protect and which ones we want to wrap in PII, and then provide any of the additional optional arguments that we mentioned. And then one other thing that we're thinking about is how would we roll this out into a production system without breaking things and causing havoc. So the way that we're thinking about doing this is by just introducing some configuration options. So for example, ultimately, maybe you want to raise an error if unmasked PII is shown or is used in production. But rather than just merging that in and breaking your service, having a way of detecting it and then isolating those call sites so you can go in and fix it is pretty important. So by supporting different sort of strategies, we can make that integration easier. So for example, what you might have in the test environment is maybe in the test environment, you do want to raise an error when PII is unmasked or is accessed in an unmasked way. But then in production, maybe initially what you want is to log where that call is happening and then allow the unmasked call initially so that you can then go back and go through the log and clean things up. So this is one example of how this configuration could be used. So this would be like the toString method override that's in the maskable value parent class. And you can see you just grab this whatever strategy was set in the configuration, and then based on what sort of strategy you have, you can either raise an error or perform logging, or simply return the masked value. And then lastly, in the code samples, this is just a really simple illustration of what we would like to have for a framework like Sidekick, for example. So basically, the idea here is if we introduce some sort of middleware so that anytime a Sidekick job is called, we get this automatic wrapping of the maskable objects. And the idea is that then when your job actually performs, you get that masking for free. So the parameters you pass in are not, perhaps they're not maskable objects, but due to the middleware stepping in, it's able to wrap them and provide that protection. Cool, and then the last thing I'll mention here is that one alternative that we sort of looked into was this idea of using parameter filter, which is, this is an object that you can use. It's already implemented in active support in Rails. But basically what this does is you, given a hash-like object with keys, you can specify a list of like regex or strings or symbols to filter from that hash object. So this is a useful tool, but the main issue that with this one is it requires you to anticipate ahead of time exactly the form that your PII is going to take. And so it places a burden on the programmer to like specify this comprehensive list of regexes or strings to catch all possible matching keys. And so it's sort of like the trade-off between a ban list and an allow list. Here, this is sort of like the ban list approach, and you're always having to kind of play whack-a-mole and think about new edge cases. Whereas using like the maskable gem, for example, you can explicitly protect your attributes by enshrining them with the method calls. And I think that's all we had. So thank you.